So the reason why different regions have sea level rising at different amounts is because of patterns of ocean currents. The land may be rising or subsiding natural based on the local geologic conditions. So the land itself might be moving up or down based on the tectonic plates, and the ocean currents may cause more rising than others. So that's why it varies from city to city, from region to region. Then we get into places like the Maldives, which are a small island country. They're home to 1,200. They're a nation of 1,200 oceans in the 1,200 islands in the Indian Ocean, and most of them are less than 1 meter above sea level. And they may become climate refugees as if sea levels keep rising. Four-fifths of the land lies below 1 meter above sea level. So there's basically no mountains. It's all just flat with sea level. They've been experiencing flooding and drinking water being contaminated as sea levels rise. The storms have intensified because of warmer water and are eroding beaches and damaging coral reefs. In 2009, the Maldives held an underwater cabinet meeting to bring attention to the plight of their country. So this is the minister of something in agriculture. All these leaders held an underwater meeting where they signed something in order to pledge that they were going to work against climate change and take care of their country. And some of these leaders have even looked into buying property in mainland nations in case one day their nation needs to be abandoned. So they've been looking around for land for their people to go if suddenly, literally, their island is underwater. And their leaders have played a big role in international efforts to fight global warming. In the United States, Superstorm Sandy, like we were talking about before, where storms have gotten worse, it demonstrated the potential havoc that storm surges can cause. So remember, storm surges are rising sea levels associated with a storm. And this storm caused $65 billion in damage, killed 160 people, and left thousands homeless. It basically destroyed the Jersey Shore, all the homes and boardwalks. In New York, economic activity came to a halt during Sandy as tunnels and subway stations flooded and cars and buildings were damaged. And Superstorm Sandy was not caused by global warming, but it was facilitated and strengthened by it due to the increase in ocean temperatures. So I don't remember if I said this, but it was a hurricane. It was hurricane status until it reached land, and then it was just a big storm. But remember that warm water speeds up hurricanes because that is more air and water to rise and to strengthen the winds in the hurricane. So it was just this crazy storm. And it's not because of global warming. There would already be hurricanes. Those are natural, but they get worse and worse because of the rising sea temperatures. Because they boost the chance of large and powerful hurricanes. Okay, so here are all the reasons why storms have gotten worse. Warmer oceans boost the chances of large and powerful hurricanes. Warmer atmosphere retains more moisture than a hurricane could possibly dump onto land. A blocking pattern in the jet stream that we talked about contributes to Sandy's energy because it traps the weather instead of allowing it to move. And higher sea levels may magnify the damage caused by storm surges. Another superstorm that was affected with the rising sea levels was Hurricane Katrina in 2005. Across New Orleans and the whole Gulf Coast, it caused $80 billion in damage. So New Orleans as a city is below sea level, and it's on the coast. So it's protected only by levees that can fail, which is what a lot of what happened in Hurricane Katrina that caused so much flooding in New Orleans. Oh, this is Superstorm Sandy. So in Hoboken, which is in New Jersey, across the way from Manhattan, all these taxis were flooded. Down in Long Island, probably. Shoreline homes toppled by storm surge. So as all this water rises from the storm, just floods everything around it. And there was even a big fire that took place in Queens during this storm as well. Currently, more than half of the U.S. population lives in coastal counties, and 3.7 million Americans live within 1 vertical meter of the high tide line. So that means that 3.7 million Americans their homes would be underwater if the sea levels rose 1 meter. South Florida is in the worst position with 2.8 million people and 1.8 million acres to be vulnerable to rising sea levels. So basically what this shows is how it would be affected by 1 foot, 2 foot, 2 feet, 3 feet, 4 feet, etc. So it's pretty crazy. And the IPCC predicts sea level will rise between 26 to 82 centimeters or higher by 2100, depending on how we regulate emissions between now and then. New research since then has also found that Greenland ice, so remember Greenland is that nation that's east of Canada, it's all ice. Their ice is melting at an accelerating rate. Not only would this affect the weather in Europe because it would mess with the warm currents that bring warm weather to Europe, but it would lead to rising seas even more than the IPCC predicted. These new estimates say that they could rise as much as 1 meter or more by 2100. And that would put half of the US population that lives in coastal areas and 3.7 million Americans live within 1 vertical meter of the high tide. So that's what they're predicting now. Then we also have oceans acidifying, which is really affecting marine life. We talked a little bit about this in our marine unit. As carbon dioxide concentrations in the atmosphere rise, the ocean absorbs more CO2. This makes seawater more acidic, a phenomenon referred to as ocean acidification. And so far, oceans have absorbed roughly 1/4 of the carbon dioxide that we have released. As seawater becomes more acidic, carbonate ions become less available and calcium carbonate dissolves, jeopardizing marine animals that produce shells. So basically, these marine animals, corals, clams, oysters, mussels, and crabs, pull carbonate ions out of the ocean and use them to build their calcium carbonate shells. So as the calcium carbonate or as the carbonate ions are disappearing because of the ocean acidification, they cannot use calcium carbonate to build their shells. And we've seen a 26% increase in acidity. That is because of the global ocean chemistry decreasing by 0.1 pH unit. So it hasn't dropped from like 7 to 6, but if it started at 7, it dropped to 6.9. Impacts of the ocean acidification on coral are apparent, and acidified seawater has now killed billions of larval oysters, so young oysters, in the Washington and Oregon regions, which has jeopardized those industries there. It's a big industry there, and now there's not anything for them to farm. So far it's dropped 0.1 pH unit. By 2100, the IPCC predicts that it would decline by another 0.06 to 0.32. So it could go, if it's already gone 0.1, it could go 0.06 more, or it could go 0.32 more. So it could be down by 0.42 of a pH unit, which would be enough to kill most of all of our living coral. And coral has 2 additional risks as well, actually. The warmer waters contribute to coral bleaching, deadly coral bleaching, and strong storms physically damage reefs. So coral is definitely in danger because of climate change. In addition to the marine animals, climate change also affects organisms and ecosystems. So many biological phenomena that rely on temperature have been modified due to global warming. Biological phenomena are things like migration or mating or things like that, or blooming time. So for example, in the spring, plants are leafing, insects are hatching, birds are migrating, and animals are breeding earlier because it gets warmer earlier because the winters aren't as bad because the global temperatures are rising. And changes in this timing can create mismatches in seasonal timing. So for example, if there's a bird that's eating a leaf that now is blooming earlier, then it's not going to have its food source at the normal time it is. Your book gives an example of these baby birds not being able to be fed. Or maybe their mating schedule is off because they're eating earlier or whatever it might be. So it is really that the timing mismatches can cause big effects in an ecosystem. And then many animals are expanding their ranges towards cooler areas, higher in elevation or latitude, because it's cooler there. It's too hot where they live right now. So for example, this is a pika. It's a little rodent, and they're disappearing from mountains after being forced upward. So it's too warm for them to live down here now, so they have to move upward higher in altitude. And the IPCC says that climate change could threaten 20 to 30% of all plant and animal species with extinction. Okay, so going back, we are going to talk about many different ways that climate change is affecting people. Oh, just kidding. We're going to talk about many different ways that climate change is affecting society and culture. The first is agriculture. So moderate warming may increase agricultural output, If it's a little bit warmer, plants get to grow for a little bit longer. They'll be healthier in the warmer weather. So a slight increase could be beneficial, but for the most part, it will increase droughts and it may diminish yields for many. Also, some crops become less nutritional when when supplied with carbon dioxide. Sorry, some plants become more nutritional. Some crops become less nutritional when supplied with excess carbon dioxide. And if the rainfall keeps dropping in certain areas, it would lead to intensified floods or droughts and will cut into agricultural productivity. So the first way it's affecting society is agriculture. Another way is forestry. So the forestry industry is a really big one, but increased carbon dioxide may spur higher timber growth. So it could lead to more timber growth because remember that CO2 is the input for photosynthesis, but warming temperatures also increase the rates of invasive species, fires, and disease outbreaks like the bark beetles. It also leads to longer, drier, hotter fire seasons. So far we have agriculture and forestry. Then we also have health effects. The warmer climate exposes us to many potential health hazards. So we're losing the risks associated with a cold climate, like the diseases that come in the cold from being inside all the time, or the suppressed immune system, or the hypothermia, whatever it might be. But these come with warmer temperatures, more frequent heat waves, and people can get sick with heat stroke. Respiratory ailments due to more photochemical smog. Remember that photochemical smog is a secondary pollutant caused when sunlight interacts with these chemicals. If we have more sunny days, there can be more photochemical smog. Expansion of tropical diseases such as malaria into temperate latitudes. So just like we talked about that little pika moving northward or moving up a mountain, these bugs like mosquitoes can move more north and more south in their latitude if it's warmer, which has led to an increase in malaria, West Nile virus, Zika, all that sort of stuff because it's warmer and the mosquitoes can live there. Disease and sanitation problems from flooding of sewage treatment plants if there's too much water as the water levels rise, and injuries and drowning from worsened storms. I mean, Superstorm Sandy and Hurricane Katrina are good examples of that. Then we also have national security. So climate change can contribute to humanitarian, geopolitical, and national security problems. So economies and infrastructure may be weakened by this, like we just saw for the Maldives example, for example, or if countries' main source of income is agriculture and that's affected, and weakened economies and infrastructure can lead to war. Oil and gas flows can be disrupted. Oil has been a big source of war, also that the U.S. has fought in. People in some affected regions may become refugees or turn to terrorism. So actually, national security experts have linked climate change and drought to the origin of the war in Syria, to conflicts elsewhere in the Middle East and Africa, which has led to a refugee problem in Europe as people are fleeing these wars. And all of that is because of climate change, or has a cause with climate change. Then we also have the economics. So economically, climate change is expected to widen the gap between the rich and the poor as people with less wealth rely more heavily on resources likely to be disrupted. That makes sense. If you have to farm and to feed yourself and you are losing your harvest because of climate change, then you're just not going to be able to feed yourself. That's not going to affect one region's farm failing is not going to affect us when we buy food from a grocery store, but it may from other people. We have what's called the social cost of carbon, which is the economic cost of damages resulting from each ton of carbon dioxide we emit. So if we say that for the per ton of carbon dioxide we emit, the amount of economic damage we're doing. So it's estimated to be somewhere between $10 to $350 per ton of carbon dioxide emitted. They said that in the US it's about $40 per ton. And the Stern Review on the Economics of Climate Change concluded that climate change could cost the world 5 to 20% of GDP by the year 2200. GDP is gross domestic product. It's all of the money that is made. So we could spend up to a fifth of all of the money that's made on climate change. And impact varies by region. So basically, in the Arctic, ice sheets are melting, sea ice is thinning, storms are increasing, and native people and animals are having more difficulty hunting. The Arctic is being hit really hard because their temperatures are rising a lot. Polar bears hunt on sea ice as the seals come up. That's where they get their sources of food, and the sea ice is thinning. These are a bunch of ways predicted climate impacts of climate change in the United States. So take a look at that. And temperatures in the US are predicted to rise another 1.7 to 5.6 degrees by the end of the century depending on how quickly emissions are reduced.